is this something we don't need?
That's just for the decision tree. Blank piece of paper.
Right on the one you need.
Yeah. Yeah, I just use scratch paper for that. So. Thanks, guys. Okay, this one is written up. Predictors of response to cognitive behavioral therapy and medication for the treatment of binge eating disorder. So originally, this was a random controlled trial looking at CBT versus fluoxetine for binge eating disorder. But in this part of the study, they wanted to see if they could come up with predictors of success of the treatments. So they combined the two treatments together and got an outcome score based on improvement in binge eating. I forgot what the scale is called, but there's a scale that gives you that. Then they wanted to see if, ahead of time, they had measured whether the person had a history of a psychiatric disorder, whether they had a personality disorder, measured self-esteem. They measured eating disorder examination, EDE. They measured depression, negative affect, and over-evaluation.
How many were there?
1, 2, 3, 4, 5, 6, 7 things they had measured ahead of time. They wanted to see how well those could be used to predict their improvement on their binge eating scale. CBT and fluoxetine, but so for this part of it, they didn't care which one they were in. They just looked at the whole sample, see how much they improved in binge eating.
So is this a two-part question?
No. They already did the study comparing fluoxetine to CBT, so that's not the issue here.
So now they're just trying to predict.
Now they're trying to see which of those things could predict how well people did with either of those.
They looked at the combined score.
They looked at an improvement score in binge eating. So they get a single number for each person. That's how much did they improve in their binge eating.
And is it, you said how much do they improve? Is it improvement or not improvement?
No, it's a score. It's an improvement score.
Each of those 7 items, they got a separate score.
Yes.
Oh, it's like, well, there's 7 measures, there's only one outcome.
7 measures to see about binge eating improvement. 7 things, they gave them 7 things ahead of time before they got into these trials. And they want to see if those 7 could predict their binge eating improvement.
But there's one score at the end.
Binge eating score is 1 score at the end.
Okay, that's all right.
Including in the multiple regression which group they were in as a dummy coded variable. And then you can see if that's significant or not. That would tell you whether the prediction held for both groups. But anyway, you had lots of DBs, no IVs, could divide predictors and outcomes, yes, 1 outcome, score data, multiple regression. Good. Keep on going until we all get them all right every time. Okay, so today I think rather than go back over the theory behind it, let's just do a factor analysis. I gave you the output. We're going to kind of merge into, from exploratory factor analysis to confirmatory, kind of a fun thing where we're going to get on and do another data set with Amos. I'm going to do one for you, and then I'm going to give you, and we're going to do, you're going to do, for this data that you put on, we're going to do an exploratory, and then you'll interpret it. So basically what you have to do is do it yourself, and talk to your neighbor, decide if you can, what you're going to call the factors, then we'll come back together and we'll see if we can agree on what those things should be called, but they got the same thing. Then we're going to move into using AMOS, which is a graphical interface program on SPSS, which lets you draw the boxes and the circles and the arrows and make pretty pictures that often don't mean anything, but they're really good. And we're going to, so I'll take you through one that we did before, that weight loss one with a path analysis, just to sort of show you how easy it is to do in there. And then we're going to do a confirmatory factor analysis on the data from here. We're going to cheat a little bit. We're going to take the exploratory factors, which we're pretty sure are going to work, and pretend like that was our theory, and then test the theory. Confirmatory, you have a series of latent variables that you're testing to see whether your data actually fits it very well. So AMOS gives you 1 million fit indices. The book has a really good elaborate guide to that, how to do AMOS. So I didn't make any handouts because I think it's right in here. So you'll see it's a complicated set of procedures, but the book kind of takes you through them, so you won't remember them. I never remember them when you're doing them myself. I have to go back and remember how to do it. Plus there's a bunch of YouTubes out there that take you through it too, which are quite useful. So that's what we're going to do. Okay, so this first one, the one you have in front of you, is a good-sized data set that was collected to try to determine personality tests. 369 subjects, rated all of these personality descriptors that you see in your first page there on a 1 to 7 scale, how much they apply to themselves. All right, so I try to give you the labels a little bit on the first page so you can actually see what they are. Kind of go on to this next page too. The theory here being that there are not, I mean, we have 45. I think 45 personality descriptors. The theory is there's not 45 personality traits. There's some set of personality traits that would be a reduction of those 45 down to 2, 3, 4, 5, 7, however many there might be. Right, so that's the task. So if we were trying to see, okay, well, let's just come up with a bunch of personality descriptors of how people are, and then see if we can come up with sort of combinations of some of those traits that go together, and then we'll call that something. And that's where the art comes in. You just sort of make up names for these factors. And then move on to the next stage would probably be confirmatory then, to take those factors, go to another sample. We're going to cheat and use the same sample, but usually go to another sample and see if they really hold up on another sample and maybe several more samples. So of the personality tests that you have heard of, the NEO and the 16PF, you guys ever heard of that one? 16PF are the two that are factor analytically derived. MMPI is not. MMPI came out of some psychiatrist's head, put it together, and if you actually look at the items and if you do factor analyze the MMPI, it doesn't at all come out the way the subscales show on the MMPI, even in the MMPI-2. However, there are 1 million factor analytically derived scales in the MMPI that are out there in the literature for everything you can imagine. There's one for predicting minor league baseball success. There's one called the worried breadwinner scale. There's one called everything. And they don't work very well, as you probably have learned. Personality doesn't really work very well as a predictor of much of anything, but it's not very stable. But these kinds of words work this way. Okay, so here's the traits. So the steps you go through are making sure there's no missing values is the first thing you want to do, because it throws out the whole case if there's a missing value. But we have no missing values here. So you do analyze. Maybe I should turn this light off because you might want to come closer. Just kind of can't see. Dimension reduction is the subheading, another factor that uses all factors. make sure you don't put in like the subject number as a factor. Yeah, I'm sorry, take two. So I'm going to put in all of these descriptors into the variable. And then you only have a few choices to make. You can ask for descriptive statistics if you want, like initial descriptors, I'll do that. You don't need anything else here. Oh, you can do the KMO and Bartlett's test is first, these are a good thing to do. So on that first page under descriptives, do the KMO Bartlett's. Under extraction, this is where you make your choice of what you're going to do. Usually you want to look at a scree plot. We didn't cover that in the slide. Did we do that in the slide? So this is a 5-letter word for rubble at the bottom of a mountain. New York Times crossword puzzle, scree. Scree, and the slides I gave you, I put a picture of scree at the bottom of the Colorado, of the Rockies. Scree is the rubble that falls down from a tor and from a cliff in a mountain. So the scree test is what they named it after that stuff, because you'll see how it plots the number of factors. So we'll look at it in a minute. To start with, we want to probably say extraction based on eigenvalues. And we'll discuss what those are in a second in more detail. So the default is just use an eigenvalue, anything greater than 1. That's called the Kaiser criteria. But we're going to do that first and then we'll come back to it. So that's all we have to do on this one. Let's continue. Under rotation, we have a choice between orthogonal rotation, which we're going to do first. So it's called the Varimax, is the most common orthogonal rotation. Remember our little bars. That means we keep the bars perpendicular to one another when we do the rotation. Or we can do an oblique rotation, and the most common one of those is the Promax. We'll do those second. Continue. Under options, a really good option is to sort the factors, the loadings by size, and suppress all the really low loadings. So you don't have to sort through them. I always do like 0.3 or 0.2. Default is 0.1, but I like more than those. And you'll see why that's an advantage in a second. And that's all you have to do. You don't use anything in selection variables. All right, so let's look at the output you've got in front of you, and then I'll explain what all that stuff is. First thing it does is just gives you the mean and standard deviation of each item. Pretty obvious. And the number, so we'll bother with those. This one, the Kaiser-Meyer-Oken measure of sampling adequacy, is a measure of whether there's enough intercorrelation among the items to be factorable. Right? So let's say that all these items correlated with one another 0, and the factor analysis can't work. So is there an adequate amount in this one? And you can see that there's numbers like at 8.840, it's like a correlation of 8.84. So there's a lot of correlation. There's a lot of common variance among those factors. So it looks like a very adequate sample to do a factor analysis on. The Bartlett's test is another one we can use for that, which also does similar kinds of things. Looks at the sum of all of the different correlations to see if it gives you a significance for that one.
We have that on our.
I didn't put that one here.
Oh.
Yeah, I'm sorry, I forgot to check that box.
Kaiser-Meyer is what again?
It's a test of whether there's enough intercorrelation among the items. The items are the particular variables, right? All personality items. Whether there's enough intercorrelation to do a factor analysis. And it kind of gives you a number like a correlation coefficient, so numbers like 0.6, 0.7, 0.8 are pretty high.
So it's doing like a little mini factor analysis between each of the scales?
Well, it's doing a sum of all of the correlations. It doesn't do any factoring yet, but it just says, is there enough correlation among these groups to be able to do this?
Okay.
So So in almost all cases, that'll be quite high.
Okay.
But if you ever did one that didn't come out, then there's no point, you're going to get a weird factor analysis that isn't going to work.
And anything over, you wouldn't want 1. You would want something really.
Perfectly, it usually won't come out to be a perfect 1. Could be 0.9.
So you do want 1. Yeah.
No, it just means it's okay to go ahead. If you get too high a 1, you're probably going to eliminate some items, or maybe some items that are perfectly correlated.
Okay.
That'll show up, that's okay.
Okay.
But this is just telling you, can you even go to the next step?
Okay.
I forgot to put it up here. Okay, the next thing it shows you are something called communalities. They did give you those, didn't they? So communalities, let me actually skip that for a minute and go to the item value for a minute. Your plot. Here's the loadings. If we understand the loadings, then we'll go backwards from there. So the loadings are, in this particular case, it did a whole bunch of factors all the way out to 45, I think. Maybe it just did 12. Yeah, it just did 12. Because it found 12 that were usable. So these numbers, which is called a loading, is a correlation between that item, 1 to 7 scale for that item, and the imaginary centroid that we did when we did our bar. Right, so we made up a new variable made up of that bar that went through when we did with our fist, remember? And we did, and it so happens the cosine of the angle between the bar and the axis is the loading. It's a correlation. So this is a correlation between the item and the centroid that we have. Right. So any items that are very highly loaded means that they contribute a lot to it. What I did is I suppressed the really low ones here. That's why there's blanks in here. So anything below 0.3, I just suppressed it so we don't have to look at it, because those aren't very important. So these are the items down here, and we sorted them from the first to the second to third. That kind of give us what we want. They give us the loadings, the importance of that item in defining that factor. And the column of these things is called an eigenvector. The column of loadings is called an eigenvector. And if you square these numbers and add them up, including the ones that I suppressed, you get something called an eigenvalue.
Square what?
You square the loadings and add them up, going down the column, you get something called an eigenvalue.
What did you say about the numbers and the importance of something?
It's like a correlation, so the higher the number, the more that contributes to that particular factor, or the principal component. Right, so you'll see when we name it, we're gonna do a couple of manipulations, and we're gonna try and figure out what they mean. So this number right here for the first principal component, I'm using principal component as one sort of a factor analysis that you could interchange the word factor for that too. Those are the same things, roughly, generically. One kind of factor analysis is principal component, which we're going to use mostly. So this number, 7.532, is all of those numbers in the first column squared and added up. And you can think about it, it's roughly, it's an arbitrary number, but if you divide it by the total number of items, which are 45 here, then you actually get a percentage of variance accounted for. So 7.532 divided by 45, I think I counted that right, should be 17%. So that tells us that before we do any kind of rotation or anything, the first factor accounts for 17% of the variance. The second one accounts for about 11.5. Third one for about 5.5. Fourth one for 4, 7, etc., etc. So that gives us some idea how important those factors are, because if the loadings aren't very high, that means that they're not going to be very important, not very important to them. Over here it gives you this, after the rotation, So you can see it spreads out the variance a little bit. So instead of 17%, it's 10%, 7%. That's where we're moving those bars around, trying to get a little bit better fit for some things bigger, some things smaller. In this particular case, the way it worked was it kind of spread the variance out among the first few factors especially. The eigenvalues were kept because we told them to keep everything above 1, so it went down to 12 items, 12 factors before it stopped. But it's very unlikely we're going to be able to interpret 12 factors, so we want to decide how many factors to keep, to retain. So that's going to be next. The other thing that we can see from that factor loading matrix is, if you take the numbers, remember these are really numbers that they're just suppressed right now. You square them across the 12 and add them up. Those are what get you the communalities. And the reason for that is that you can look and see whether the item actually loaded somewhere. Right? So if the number there was a very low number, that would mean that all of its loading squared and added up didn't amount to anything. So that item just never found a place, it never found a home among the 12 factors. So that would be a reason to drop that item probably. It's not giving you anything. In real life, these items actually cost you a lot of money each to kind of try on them. Every time you do a new thing, you have a whole bunch of subjects, it might cost you $50 each to have an item or something. So if you got a bunch of items in there that don't contribute, you want to get rid of them. So here we can see the lowest one.
Explain that point again. I'm not sure what you mean there.
So if you took the loadings, right, you've got to think about what those loadings are. Those are correlations between that item and the factor. Now we're going to factor 1 through 12 here. And squared it, so 0.666 squared plus squaring 0.636, 6363, and there's a bunch more here that I just suppressed. Go all the way across. That item, leadership ability, here. Leadership ability, somewhere, right?
There it is.
Yeah, so all of those together came out to 0.683.
So that includes the ones that you suppressed?
Yeah, it includes the one that the suppressed, just so I don't have to, so when I'm looking at them, I don't have to be influenced by ones that aren't very important. You don't have to suppress them if you don't want to. You can leave them all out.
What page is the 0.683 on? Visually, it's hard to see.
I think it's on page 2.
Should be right after the descriptive statistics. The next thing under communalities, the first time you see the communalities. So in this particular data set, there's one here, analytic, which is pretty low, 0.397, not horrible. And that's the lowest one that I see there. So we might want to consider later that analytic never really loaded in anything very interesting. And that might be one to look at. Are you with me? Okay, so now we know what eigenvalues are, we know what communalities are. If we look at the screed plot now, what it does is it plots component number versus the eigenvalues. It just gives you a visual interpretation of how they fall off in terms of how many you might want to retain. So this is fairly arbitrary. You could see the first three look like they're pretty decent. Maybe the fourth one, maybe the fifth one. Somewhere in here they're just pretty redundant. They're not giving us much more. So somewhere, this is the scree at the bottom of the hill, right? So somewhere you can make a decision that maybe we retain that. 1, 2, 3, 4, whatever we want to do. The other way to do it is to just look at the factors themselves and see whether they make any sense or not, and then just decide on, you know what, I think I'm going to stick to 2, 3, 4, 5, however many I think I can meaningfully get out of this. This is usually the way people do it. So if we look at our component matrix, but we always want to go look at the rotated component matrix, because that gives us the clearest picture. Here are the factors that we have. The first factor is dominated by forceful, assertive, strong personality, dominant, act as a leader, leadership ability, willing to take a stand, and makes decisions easily. To a lesser degree, self-sufficient and willing to take risks are pretty unimportant. Negatively, we have a few like shy and soft-spoken. If there's negative loadings, that means it's a bipolar factor, that it has both positive and negative items. Some of them do, some don't. Some just have only positive. So to go from 0 to something, or to go from negative to positive, and you can decide. And so the items, clearly the items here are the opposite of forceful and assertive, right? Like shy. So this one, but these are pretty low loading, so we might not worry about those. All right, so what would you call that factor?
Type A personality?
Okay. Any other ideas? It's not a bad one for psychologists to kind of know what that means. Sometimes you can just name it by the, like forceful, by the leading one.
Alpha.
Alpha. Well, it's good. This is both males and females.
Pack alpha.
Yeah.
Assertiveness.
Assertiveness. I like type A, that's one of it. It's nice to have a name that, for later, we want a name that's different from one of those, just for convenience. Let's try type A for that one. I like
We're
that.
just supposed to refer to the entire column?
Yeah, but look at the highest loadings are the ones that are the most defining, right? So when you get a 0.3, that's only contributing a little bit. The 0.7 is contributing 0.788 is contributing a lot. So you can see the big ones up here are all kind of the same thing. All right, second factor is compassionate, sympathy, sensitive, understanding, eager to soothe hurt feelings, to a lesser degree warm, and there's no negative ones in that one. What would we call that one?
Helper.
Said mom.
Mom.
Maybe,
Dads.
maybe helper type?
Helper type, yeah. Okay.
Nurturing?
High self-monitors, we want to use a psychological one, right? These are people who are tuned into the feelings of others.
Emotionally intelligent?
Emotionally intelligent?
Yeah, that's a good one.
Okay, emotionally intelligent. Let's use that one. We'll use our own jargon, that's fun.
Sympathy, sensitive, understand.
So it's lower than one.
I mean, it just looks like empathy, well, general.
Yeah, but it's not just empathy, it's also sensitivity and understanding. Mostly, I think we would define anyone with these traits as emotionally intelligent. Right? All right, so the third one is tender. Now, this is a little tricky now, right? Tender, affectionate, loyal, gentle, warm, analytic to a much lesser degree, no negative ones, truthful to a little bit more.
Perfect person.
Best friend type.
Best friend.
For the women, it's the guys that you should be interested in, but you're not.
Thank you.
So yeah, tender-hearted, something like that, we could call that one. This one is self-reliant, independent, self-sufficient, and helpful. Helpful doesn't really fit very well there, but it went together with that one. But I mean, self-sufficient, independent, I think self-reliant, self-sufficient, and that's probably as good a name as we're going to get for those. That seems to work, though, even though there's only 4 items. We're getting down to very few items. We're going to get iffy about whether it's a decent factor. You need to have at least a few items. Now we're getting iffy about it. This one is competitive, athletic, ambitious, willing to take risks.
Fun.
Angry.
Yeah, no, not angry. It's nothing to do with angry. Just athletic.
You went on vacation.
Like outdoorsy.
Doesn't say
Like
outdoorsy, but yeah.
Think of the athletic.
Probably competitive is
Yeah.
the best descriptor, right?
Exactly.
Yeah, so it would have to be combination of competitive and athletic.
Yeah.
Maybe we call it competitive dash athletic. But there's only 4 items, so now that's getting worrisome. Now
So
we're
is
down.
4 too few? Is there a number there?
4 is not great, so we're gonna probably want to stop before then. And this one, even though it makes some sense, only 3 items, it's feminine, opposite of masculine, and yielding. But it probably works, but it's only 3 items, and then the loading, only 1 loading is really decent, although it is bipolar.
What would you do for cheerful, happy, and then moody?
Where's that one?
One
Yeah, that's
before.
the one before that.
Yeah,
That's
that's
why-
that.
What you're talking about?
Cheerful happy.
Is that's bipolar?
It's 7.72.7.
Yeah, right there.
Yeah, that
Music
one.
starts to.
Competitive, cheerful, happy, moody.
No, just cheerful.
Yeah.
Bipolar?
I'm sorry, athletic.
Yeah, well, moody was the opposite, was a negative, right? So those would be
Yeah.
very, that's the opposite of moody, but it doesn't fit very well. Moody seems like, and this is the problem you have with this. There's gonna be items that you wonder where they came from.
Or emotional?
Does that mean that they're not moving?
Yeah, these are not moody.
So
That's-
they're like
that's-
optimists or something.
It sounds like emotion.
Stable, opposite of moody is emotionally stable, right?
Positive stability.
Something like that, or something like that, right? When you look at the 16 PF and you see what they name those factors and you see what the items are, you have to scratch your head. There's one up that's called suckerance. That would be the one for the, for the mom.
Irishness.
Warm-hearted ones, that's suckerance. But you look at the items, there's a whole bunch that don't make any sense, but that's what they named them. So we probably don't want this many factors, so let's go back in and reduce down to some number, maybe 4. Would be a good number to try. And that's going to change everything a little bit because it's going to force the variance into those 4 factors. The way we do that, how many did I reduce down to 3 on yours? Maybe I did 3.
4.
Did I do 4? The second time through, you'll see another one. Three. So just since I did that, so I click back on extraction again, and instead of using eigenvalues, I say fixed number of factors 3. You see how I did that? I went to a fixed number of factors 3 then. So now I'm going to run everything again with just 3 factors retained. Most of it will be the same data, but a little bit different. So everything looks fine there. Now with the commonality, we got a couple that are really dropping out, right? So there's a point 112. So we eliminated some of the factors that included athletic, so it's no longer loads. So maybe we should have had more factors than this. The variance in the rotated variance was pretty good. First factor was about 14%, 13%. By the third, we're down to 6%. So now we're getting a bit iffy for the third one, but that's probably all right. We don't really care about that one until we get the rotated. Here's our rotated one. So now we get all the same things we got before, but a few more that got forced into it. Soft-spoken was the opposite of the forceful, strong, type A. Shy was the opposite of type A. But the basic one stayed the same for the first factor, so that really didn't change very much. So we can still call that one type A. Second one, we got a lot more high loadings when we force them in. But here it still starts with warm and tender and gentle, opposite of masculine. Down to affectionate. So that kind of took our affectionate one and put it into the second one instead. The third one is dominated by self-sufficient, opposite of childlike, conscientious, self-reliant. It's sort of that same one, but with some negative loadings. So it probably went too far to eliminate it to 3. We might want to go back to 4, but I'm not going to bother with it right now. And didn't ask for college. One of the things you want to see, I didn't do it on yours either up that, but let me just do it now. Analyze correlation. Got where that is. Now, I forgot where that is. Somewhere you can actually get the correlation between the components. Maybe that's the transformation matrix. I don't think it is. But that would mean that factor 1 correlates 0.553 with factor 2. So it's doing its best to keep the perpendicular, but it can't. So the factors it comes up with are somewhat correlated. If they're correlated, that might mean you might want to do an oblique rotation instead of an orthogonal rotation, which we're going to do next. In this case, you'll see it doesn't really change anything too much. But so all you do for that one is everything's the same except you do under rotation, instead of Varimax, you do Promax. These are very similar kinds of things. One thing that changes is it gives you something called a pattern matrix and then a structure matrix. The structure matrix is the rotated loadings. In the oblique rotation, they change the name from rotated factor loadings or component loadings to structure loading, structure matrix. And you can see it looks pretty much the same. I'm just going to clean up some of these a little bit by getting these factors a little more correlated with each other. Here we get some bigger loadings on warm, tender, might be a better solution for us. Here we got a bigger loading on self-sufficient, self-reliant.
What did you say the structure matrix is?
It's the same, that's the one we interpret, that's just like the loading matrix, the rotated loading matrix we did before. When you do the Promax, it's called a structure matrix.
I'm confused as to like what the rotations do. Like why do you rotate the data?
So remember, if you kind of remember what we did before with our bars, right?
Yeah.
We started off with the bars just in the original fixed axes, right? And we put our space there. Well, imagine that, it's hard to do this while I can draw them, but imagine that you had a whole bunch of dots going like this, and another group of dots right near it like that, right? So what'll happen is when it tries to do it, it'll try to clean up those factor loadings to maximize the high ones and minimize the low ones.
Okay.
So it's basically an interpretation technique, trying to get a better interpretation. So it might be able to do that. Let's say that the dots are like here and then like here. Then by rotating it, you'll get the lines right through the middle of the dots. And you'll get really nice clean loadings, right?
So the different types of rotation are different interpretations of the factors.
Yeah, well, so we're only going to use two. We're going to use the orthogonal maintains perpendicularity among them.
Okay.
So you move those around, but you have to keep them in 90-degree angles to each other. So you do your best to get the fit. Okay, what if I imagine it, because it does it sort of by trial and error. Move it a little here, move it a little here. What it does is it looks for maximizing the high loadings and minimizing the low ones to try and get a more interpretable solution. But another option is like the first case I gave, if you have two dots like this, well, maybe you don't want to keep them perpendicular to one another. You can make them on an angle to one another. Then you get the line right through those dots. That should give you a much better interpretation. So and there's arguments about which is the best one, because we'd like to have factors that are sort of independent of each other. We don't want them too correlated, but maybe somewhat correlated is good. In this case, I think we got a better solution with the Promax than we did with the Varimax. And I think in the real study, they used an oblique rotation, either quartermax or prolmax to do it. So you have to kind of realize that the price you're paying is that your factors are not completely independent of each other. You're not even requiring that anymore. So you're thinking that maybe the way it works is that the leader, the type A, is somewhat correlated with warm and tender or something, whatever they want, which doesn't seem right, but could be. Could be the process as well. And that's all that that's really for. Okay? Okay, so now one other thing, and then we'll go ahead and try to do one. If you find out this is a solution you like, let's pretend this is the one we're happy with, and you want to use it in some future study, you need to translate this into a variable. There's a couple things you can do with it. One thing you can do, and this transfers over to your measurement class, you can see whether those factors are reliable. Right, so you guys got to reliability yet? Yep. So how do you do reliability? What's the most common test of reliability? Well, not test retest reliability, internal consistency, sorry. What's the best test of internal consistency? Spearman Brown is one. What's some other ones? I'm going to tell Dr. Mano I do. Well, it turns out in SPSS, internal consistency is actually a total piece of cake. So all we need to know is which items these are. Look on your thing and give me like the top 10 of the first items. I don't know what an item number there from this one. Can you tell from the first page? I think you can, can't you? So I'll give you the one. Look up and tell me what number it is. Somebody write down those numbers. Leadership ability. With me? Leadership ability. Look on the very first page.
Yeah.
What number item is that one?
23.
Okay, somebody write that down. Act as a leader.
38.
Okay. Strong personality. Nobody see? I think you have to see it. 11.
11.
Forceful. There it is. 12. Dominant. 29. Willing to take a stand.
25.
I'll just cut it short. But what you would do is put all those items. Make sure you know which items they are. Then in SPSS, you just go to scale, reliability analysis. Just wants to know which ones. Oh, we didn't need the numbers. Sorry. Okay. Just tell me which ones those were again.
Leadership.
So first one was what? Strong personality was one of them, right?
Yeah.
Assertiveness was one of them. Wasn't that it? No.
Yeah.
Well, it can be.
Yeah, it would be. Yeah, we can put it in. Let's just kind of look for the ones we want. Forceful. Did I miss something here?
Leadership ability.
Next decision.
Leadership ability. Eager. Dominant.
Willing to take a stand.
Willing to take a stand.
It's like, I mean, I'm just looking at
Is there any more? Okay. So you just put the ones in that it's supposed to be. You can decide to do an alpha coefficient, which is the usual best one to do. And you can get more things. You can get descriptions for the items. You can get item to total correlations. Remember that from measurement? You can get an interclass correlation coefficient. But anyway, you just do that, and it gives you Cronbach's alpha. That was the answer I was looking Chromebox Alpha is the most widely used internal consistency measure. So here Chromebox Alpha was 0.834. How is that?
Good.
Good.
Good. So we came up with a scale that has good internal consistency at least. The items are all work. And then you can actually ask for, I guess it didn't ask for, you can ask for how much does each item correlate with the total score to see how well the items work. You guys talk about that measurement yet? Item to total correlations.
You did like item to item.
You can do item to item, but you also can do item to total to see how does that item work in the total score. Right? If it's a bad correlation, then it probably is the one of the items that doesn't belong in that scale. In this case, I don't think any of them work that. Okay, the other thing you can do, going back to the factor analysis, if you want to use that, let's say we wanted to use that type A in a future study, in a regression study, to predict something else. Well, how are we going to do that? Well, we need the computer to give us a score for each person on that scale, right? So we do that by just asking it to save scores. One of the things I skipped when you did it under options, oh, I'm sorry, under score. So there's one, this tab score. You just say, click save as a variable. And then say OK. Now what it does then is it creates a bunch of new items for each person, which it calls factor 1, factor 2, factor 3, and those are called factor scores, or component scores, factor or component scores. And the way it does it is it takes all those persons' scores on the items that went into factor 1, forceful, dominant, active leader, those loadings. It multiplies those loadings times the score that they gave on the 1 to 7 scale. 7 standardizes them, but it does basically that. Adds them up and gives you a score for that one. These are sort of arbitrary numbers, but that particular person was 0.359 on the type A scale. Pretty kind of medium. Here's a person that's very low on it. Somewhere there should be some people that are very high on it. Let's see, here's one pretty high. Right. So we then get the factor analysis turns into an actual scale score for that person for each of the factors that we retain, or components we retain. So now I could rename that type A, go into my variable view and type in type A, if we call it that, and then use that in a regression against something else, some other variable that I want to use in another study. So when you want to go from factor analysis to regression, you want to use factor scores or component scores to do that. That's the way to do it.
And do they come out as a standard score?
It comes out as a standard score because it's worried about
With a specific range, right?
yeah, well, the range like all z-scores kind of from +3 to -3. So it's kind of but it has a lot of decimal points, so it has enough range within that. And that's just for mathematical reasons to keep the numbers equivalent. In this particular case, since all the scales are exactly the same, you could actually multiply it 6 times the factor score for that person and add them up if you wanted to get something reasonable. But often, sometimes you can't do that. So you'll get as many of those as the factors you retained. So then you want to go back and rename them because nobody knows what factor 1, factor 2, factor 3 is. So we have our names for those. We could use those then in another study. Let's see. Video game aggressiveness or something. We're doing a study on that. We wanted to see if type A personality style predicted video game aggressiveness. This would be what we'd use that column of numbers as our predictor. Pretty self-contained one. Okay, so on your computers, I put some data, some real data from a UCLA study looking at faculty ratings. You know, the faculty rating scale that we use. If you look at that scale, you know it wasn't factor analyzed because there's so many items that measure the same thing. So what we tried to get them to do, which we can't, is to use a factor analytically derived faculty evaluation scale, which would give you way fewer items to check, and you wouldn't be checking the same items the same way. But we don't know what the components of that would be, right? There probably are more than one thing that defines good faculty. So you've got a very simple one. I think there's like 14 items that were done for a big sample of UCLA faculty. And what your job is to figure out what are the components, how many to retain, what do you want to call them. They're all labeled in the variable view. That's the data we put on your computer.
So, let me get this straight. So we have a whole bunch of factors. We're going to end up with like a couple factors that are going to make a good business teacher, and a couple factors, or things that are going to make a good like.
No, I think it's like you combine the when you're filling out the survey, you want to combine the things that say like, did you learn what you were supposed to learn in this course? Did you learn everything you were supposed to learn in this
More applicable to
course?
every
Like
professor.
3 things that say like the same kind of thing.
Yeah. So what do you
So
think?
we're only finding one type of good teacher, not.
No, yeah, we're not. It's not by discipline.
Okay.
We're not doing it by discipline. That's a whole different
Just
thing.
like Uber teacher.
We're just saying what are the components that make a good university professor. So what knowledge of the subject probably is one.
Facial hair.
Willingness to availability to students. You'll see what the kinds of possibilities are.
Did they use multiple modalities of teaching?
Yeah, this one doesn't have all of those things in it, but you'll see it. I just made it simple enough so that you can do it. So go try that, and do it yourselves, and then talk to somebody near you, see if you agree on what to call it. So, well, we did a regression over the years of people coming, looking at undergraduate grades and some other predictors of success in our program. Came up with a scale of success. And undergraduate grades were the best predictor. Then we looked at, in the equation, we put in graduate master's level, grades in your master's program. And not everybody has a master's, of course. And that came up with a decent negative correlation to success in the program.
Well, I can think of 2 possibilities. Maybe some of the individuals that had upper or master's or upper division credits and whatnot ended up failing out of the other program. They tried to join this one. And in that case, their grades would be lower, success would be higher here, potentially. And the other option, well, because their grades failing out at another school and success here would be a negative correlation.
Possible, that wasn't it.
The other
We were looking at success
The
in
other-
our program.
option,
Yeah, people typically get all A's and B's in their graduate programs, almost all A's.
Life circumstances.
Too much debt load.
So remember, not everybody, the clue is not everybody does a master's program, right? Yeah, that's what happened, is the ones who did the master's programs were ones who had lousy undergraduate records often and made it up by going a master's program first. So choosing to do a master's program tended to be associated with weaker students, as opposed to people who came out of good universities with grade points and going right into the doctoral program. It wasn't completely true. Some people were, of course, exceptions. But it ended up being sort of a negative predictor of success, because we look at someone with a 2.3 from Cal State, blah, 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 and then a 3.8 at a master's program. And it turns out those people, and in the early days we took some of those people because they had the masters, they did very poorly.
you say a 2.3?
Yeah. So-
You can get into grad school with a 2.3?
Well, because they had all A's in their master. We don't do that anymore, but for a while, if they said, oh yeah, well, they prove they can do graduate work, the graduate level, so we'll let them in.
You get a
They
little
did so
master.
well
Well-
in masters, why did they do so poorly there?
They did great in the
Because
masters.
of the
Right, they
different.
did so well in their masters.
Because the
But it's rigor.
masters, these masters programs, everybody gets good
Yeah,
grades.
it's
I
a
mean,
function of the rigor.
It's really rare to see.
University master's programs or like?
Yeah, no, university, but they still tend to be,
Still kind of a gentleman's course.
I mean, where would you have gone for a master's degree? You go Pepperdine, Maryland, maybe San Diego State. San Diego State, it wasn't true as much, but a master's degree doesn't get you much. So why would someone do a master's program unless they're trying to prepare for the doctoral
Fullerton has a master's in
program? It's a tough one because,
You mean in clinical psychology specifically, or if they?
no,
have
it had to be in
study
psychology.
specific?
Some were clinical, some were just in psychology. Yeah, some were clinical. a lot of them were Pepperdine, Chapman, and Azusa, places like that. They're probably decent programs, it's just that people get good grades in those programs. And if they had good undergraduate grades, then it didn't matter, that was fine.
Anecdotally, it kind of makes sense because my wife is getting her master's in education through Capella, and there's people that in her various classes, she's about halfway through now, they'll supposedly have their master's in something already, and they can't write. They just cannot convey thought in the written form.
Yeah.
In these,
And education is really something.
you need that.
My wife has an EDD, and so I got to know all the peers in her doctoral program. Some of them couldn't write, some of them couldn't speak. EDD, doctoral of education, yeah. But what happens is you're a classroom teacher, probably decent, maybe an assistant principal, right? Men especially try to move up, they get assistant principal. You can't advance without a degree. So now you get a master's at Point Loma Nazarene or someplace that they would and you go on to University of Arizona or someplace they have an extension. You can do it. My wife did it in summers. We spent our summers in Flagstaff so she could do this. Kids in there. Flagstaff's neat, yeah.
Summers and classes?
So summers are neat to get monsoons and then they blow through.
How often do you guys go to the Grand Canyon? Is that right down the road?
Yeah, we went there several times. The kids were little, so I did my bike riding up there at elevation training, so I was building up my red blood cell. All right, anyway. Thank you for the feedback. All right, now for something completely different. All right, so now I'm gonna run through a couple things in Amos, and then you're gonna do one in Amos too, which is you'll need some help with because there's a lot of steps. But the book is good, so you can look at your book on that. What I'm going to do first is that same example we did with the weight loss. I'm going to do it on Amos, and then we're going to move towards confirmatory. So you can use Amos for path analysis, which is a kind of neat way to use it. It's probably went off. So what you do in Amos is first you load a data file in SPSS before you go into the Amos pull down. So you remember the one I did with exercise, metabolism, weight loss. It's a very dumb little example because it's a very small sample size, but I just want to, it works. So I'm going to go ahead and load that data first in SPSS. It won't let you do anything in Amos until you do that. Then you go to Amos, oh boy. You guys have it on your pull down menu? Do analyze, look at the bottom. Would you?
Yeah, Amos 19.
Where is it?
I'm going to have to go get my laptop. All right, hang on, guys.
Don't worry, Rob can fix it.
And we could use one of your laptops. No, we can't. Yeah, we could use one of your laptops.
I don't know where you can.
What is analyzing what?
Sorry, I'll just run down and get mine. Take me a minute.
I just want to make sure that I have on mine.
Analyze at the very bottom, it should say Amos 19.
I don't have it.
You don't have it.
My SPSS one doesn't have it either.
Yeah, if you bought the student, you would have to pay extra for it if you bought the student version.
Yeah.
So, but you got them on these computers, so. So I'm just opening the file. as I was saying before I was rudely interrupted, we'll go down here to Amos 19. And you get this whole new deal. So there's a lot of steps to sort of kind of roll with it, and I'll take you through them again a couple more times, presuming I remember the right steps myself. Let's say file new. Supposed to be a blank screen. Huh. Usually when I do that, it just gives me a blank screen right away.
If you go into the Amos
Yeah.
is a drop down, and then go into file.
Yeah.
And now,
Oh, and the other one.
No, and the other.
Oh, that's what I'm doing wrong. No wonder. Thank you. All right, let's make this big so I don't do that again. All right, so this is your file. One thing that I think is a good idea is to make it landscape. So under View Interface Properties, gives you a choice to do portrait or landscape. It's a little easier to work with if you do landscape. It's not necessary, but it's just one little trick. What? Oh, I did. Okay. All right. First thing you have to do is tell it what data we're using. So it's view. Sorry, no. This symbol, which symbol is it? Select data file. This one, see that symbol? And I'm telling it I'm going to use this data file, and it tells me that whether there's any missing values, it's okay. So now it has that data. Now what I'm going to do is create the model first and then put variables in. So we're doing, the boxes, remember, stand for observed variables, not latent variables. The ovals are latent variables. They call them unobserved or latent variables. So what's the difference? Observed variables are one measure that we just have a number for. Latent measures are made up of several measures like factors. So in a minute we're going to do some latent variables, but first we're just going to do a simple one with path. In the path analysis with measured variables, you just use the squares. So I click on the squares, and then I could draw my little boxes the way I did before. One trick to this one, if you want to move anything, you got to use this little moving band thing. So if you want to get it looking good, you got to use this one, and then you have to unclick it when you're done with it. This little, see the little red one, move objects? Everything does tell you what they are when you put the cursor over it, and most everything is here, but some of them are on the top. All right, so let's go ahead and view the variables that we have. View variables in the data set. You can do that here, or you can also do it here too, or one of these does it, but I always do it. And you can move this little guy around if you want. So I'm going to go ahead and say weight loss was our outcome, remember? Just drag that over to there. The metabolism, I think, was we had here. Food intake was here. And exercise, I think, was here. And I got them labeled. I need to put arrows the way we want, so the single arrow is the one, the double arrows are correlations, single arrows are directive paths. So we had this path, and this path, and this path, this path, we had this path, and we had this path. One of the models we did, right? Now, any box that has arrows going to it needs to also have like an error term for it. So you basically, under plugins, you'd say, we do it that way now. This little symbol is add unique variable to existing variable. So that anything with arrows going to it, I need one of these little guys. So I'm going to do, this one I don't need it, but this one I do. And if you keep on clicking, it'll put it down to the bottom where it's out of the way a little bit. This one I need one. And obviously this one I need. I don't need it here because there's no arrows going to that box. Those need to be labeled, so under plugins you say name unobserved variables. It calls them E1, E2, E3, E4. If the thing goes off the page like that, this little symbol resizes it to fit the page. Looks like this one is now a little bit out of the scale, so if I want to, I could expand this box a little bit. Oops, wrong one. This one. Yeah. Turn something on first. Pretty sure it's that one.
That's just
There's a whole
page.
diagram.
Oh, that's the whole page. Oh, yeah. One of these is just. Oh, okay.
Can you just change the font size?
I can, but actually there's one that'll make that bigger. I just can't remember which one it is all of a sudden.
May run into your problem that you mentioned, where sometimes if it's not the scale, it gives an illusion that there's something else there. Just because weight loss is larger, it may falsely give an impression of something else.
Yeah, well, you just want to be able to see it. It's just,
Right.
it's just cosmetics. Everything else is going to work all right.
Maybe that one with the magnifying glass in the box.
No, that makes the whole screen bigger. Let's see. You can also right-click on these, and you can use touch-up. There's one that's a touch-up one that didn't work. Gosh, I've done this a million times. Oh, here, this one. Change the shape of the object.
Well, we know it works.
Okay. Now, the next step, we've got undefined, we've got these, we've got these. We want to look at, tell it what the output we want to look at. So one of the things we want to do is analysis properties. Especially we want to do on output analysis properties. I want to make sure I use standardized estimates. Otherwise it does unstandardized estimates. So that's, for now, that's all we'll do for that one. Okay, then I think I'm ready, but probably not. We'll see. So do analyze, calculate estimates. It wants you to save it. So we can save it as my document says path 2. Save. I think it works. So if it works, you get a chi-square down here. It's still running. So then I click on this one, which is View Output Path Diagram. Voila. So those are the raw regression weights that we came up with ourselves. And cross your fingers. Good. There's the standardized regression weights, which should be the same as we did in your notes. Right, so remember those, this was a negative beta 0.74, that was a 0.38. All the things we did with the path are done this way. And you can also get it to tell you how much variance is unaccounted for in each of the ones. The E's, you can get numbers for the E's if you want. I didn't check that. All right, so it takes a little bit of doing, as you can see from my sloppy display. But also you have to be sort of artistic to make them look good. So that's path, just so you see the easiest way to do it. Now we're
What
going
would
to do.
happen if we took out the E1, E2, E3? Would that change the
It
numbers?
wouldn't let you do it. It won't let you do it. These are called endogenous and exogenous variables. Anything with arrows going to it are called exogenous variables.
Mm-hmm. So basically those little circles are classifiers, and they factor into the calculation.
Yeah, because since it's multiple regression going to it, there's an error term that needs to be calculated. So those are the errors, the unaccounted for variance, which you can also get listed if you want.
Okay.
But if you have trouble running it and you don't get the chi-square, that's usually why it's something that's not accounted for in there.
Is that exogenous is going out? of it?
Exogenous when the arrows are going to them. Endogenous are the ones that are without, like food intake would be endogenous, the rest would be exogenous. We'll go through those again because we have to count parameters in a little bit. There's another thing to do later in instruction. We don't have to do that right now. So remember that would mean that there's a direct path from food intake to weight loss, which is a negative one. This is where the more food you take in, the less weight you lose. Fits. Then there's the exercise path where we'd say, okay, we go 0.52 times 0.85 to give us that indirect path from food intake plus the other indirect paths.
0.85 you said?
52, 3. Don't think you can make these bigger, unfortunately. So one thing I'm trying to figure out is how to make those look better, those numbers. But,
So what is exercise to weight loss? 0.52?
0.52. Oh, exercise to weight loss? Yeah, 0.53, I think. That's also 0.5. They're both 0.5.
Oh, it's the one that's crossed off, like.
Yeah, it's also a 0.52, just by coincidence. So those are remember, those are weights that are parceled out for the other factors, right? So we can say the relationship between metabolism and weight loss, holding constant food intake and exercise, all the things we did in path analysis. This basically does it that way for you. Okay? All right, now I'm going to do confirmatory factor analysis. Let's
Before you
talk
do that,
about
can you say about the E's? Like, what?
These are like the residual, like the unaccounted for error.
Well, what information is E1 giving me when I look at exercise?
Just the amount of variance in exercise that's not accounted for by the model.
So what is 1 referring to?
It's just numbers.
Oh, the error
arbitrarily.
exists. It's giving me the number.
You can actually name those if you want. You could right click on and name them error exercise or something if you want.
An error always exists, so.
Yeah, but it exists only in these exogenous variables. It gives you a term for that. In path analysis, that's typically the way they do it.
Okay.
You'll be able to see that. The book has a couple examples with Amos and path as well.
Can you explain that definition for endogenous?
If arrows are going to it, it's exogenous. If there's no arrows going to it, if arrows are going to it, it's exogenous. If there's no arrows going to it, it's endogenous.
There's no arrows going to it.
Look at food intake. There's no arrows going to food intake.
Right.
But there's arrows to every other one of these.
So what did you call it?
Endogenous and exogenous.
But what is food intake?
Food intake is endogenous.
I think last year we said the opposite.
Did I get it wrong?
I
Oh, it is. I've got it backwards. I'm
So
sorry.
let's illustrate.
just want to make sure because
No, you're right, I got it backwards, yeah.
last time, and so I felt that.
Yeah, you don't really need to use those words, but yeah, sorry. So exogenous are the ones that are outside the arrow. So the opposite of what I said. Arrows going to them, it's endogenous. No arrows going to it, it's exogenous. Yeah, it makes sense. Exogenous would be outside, endogenous is inside.
EX for from.
Sorry, thank you.
Sure.
Now, what you can do with this is you can ask for, when you do the data analysis, you can ask for to see how well the path is working. So let me do that again. If I ask for properties and I do output, and I also ask for modification indices, for instance. And that's the other one we would often use. And then I run the model again. Now I can go to this one is the view text. I could have just pushed that one, view text. And if I go to modification indices among these things, here they are. Estimates. So there's my estimates. And then here's what says model fit. So these are all explained in the book too. You can kind of read through them, but I'll just go through it real quickly. This one is kind of a dumb example, so we can't really do it. But basically, you would look at. I'll give you a real example in a minute. You look at these are indices of how well the model fits. These never would be one. They would be like 0.8, 0.9, 0.7. You want a bunch of them to be above 0.9. This one is the opposite. The RMSEA is one that's should be like below 0.05. This one. But you can also look at the estimates. Under estimates, you can also look at estimates of where there might be some problems in the model. And if you see some, and this example is not going to work, but you'll see it in a minute, you can see, and if you see some errors that are highly correlated, for instance, you can go ahead and change the model and redo it. So in this particular model, let's say, go back to the model, this one's not an example yet, but, and we decide maybe to take this one out. The X is the delete button. This first. Sorry, this one first. So I could take that path out, for instance, and then try the model again. Or I could try different paths. You'll see with the more complicated data sets, it gives you what's called modification indices, telling you how well the paths are working and which paths are not working. So it's a little bit dangerous because you can take a data set and go by those and fit the data to the model that works great for the data, and then pretend that that's what you meant all along, and present that as an input model. And you're not supposed to do that. You have to really say, hey, this is the way it fit best, and I can't make heads or tails of it, or now we have to do another study to see if this model will work with a new set of data. One of the dangers of this thing, really big danger, is people do kind of make things work, give you these fancy models, which sometimes are not so clearly predicted. So when you see something that the literature review doesn't give you a real clear-cut prediction, you should be skeptical about how well those models are actually working for you. All right, let's look at one that's more interesting than this one then. Okay, I want to load new data for this one, so what do I have to do? I've got to go to here, I'm going to put a new file in there, and then we're going to just use the file we used this morning now. Which is a real data file, a big real data file. And that's the one we put on your computers. So that one was called Vector SAV, right?
Can we do this on the computers with you?
Yeah, but, yeah. So let me run through it once, and then I'll run through it with you guys again. There's a bunch of steps to it. So now we're going to do confirmatory. We're going to use this to do confirmatory factor analysis. Confirmatory looks similar to exploratory, but what you're doing is taking a model. What we're going to do is pretend like we're coming up with a model from some previous literature on leadership and sort of type A and warmth and stuff. And you're going to say, we're pretending like we did this in a new data set, trying to confirm that we got a model that fits. This can be a really useful tool in a whole bunch of ways. So for instance, let's say we were trying to do something with the DSM-5. One way you could look at that is you could take symptom items and see how they actually factor, rather than doing it theoretically, which unfortunately they're not doing, but they should be doing. So if you do a DSM-4, for instance, and you take all of the symptoms that you could think of and put them into an item by item for symptoms, have people endorse them with a whole range of psychopathology, you would hope that you'd get a factor that looked like OCD, and a factor that looked like major depressive disorder, and one that looked like bipolar, and one looked like, well, some work. OCD actually works. You get a really nice, clean-cut one. Social phobia works. All the things that you would think would go into social phobia, people do. I'm afraid of being exposed, and I get nervous talking in front of other people, blah, blah, blah. Depression doesn't work at all. You get about 3 different factors for depression that look like they're all over the place. Schizophrenia doesn't work at all. All the psychotic disorders seem to all kind of run together into different factors. Somatoform disorders really doesn't work. So a lot of them don't work in terms of the factor. But one of the ways you could test how well classification systems work is with confirmatory factor analysis. You put them in the way you think they should be, and we see how well the model fits. For those of us for health, you could look at headache as a good one to look at. So the neurologists classify headaches into tension headaches, migraine headaches, and a whole bunch of other classifications. So you could take headache symptoms, every imaginable headache symptom, put it in a scale, have people coming to a headache clinic fill it out. How much does this apply to me? And you'd hope you'd see a nice cluster that would go together for migraine, one-sided, throbbing, paroxysmal pain, very severe pain, can't stand sound or light, all the things that's supposed to go together for migraine. And another one that would be tension headache, which would be more chronic, tension, a tense feeling around the head, different place for the pain, different time sequence, but you don't get a very good one of those. You get something that kind of looks like migraine with some other features in, partially because severe tension headaches kind of disguise themselves as migraine. So there's a big controversy in neurology, in the International Classification System, which did do factor analysis, and we're not so happy with what they got because their classification system kind of worked and kind of didn't work. And so now there's lots of arguments about that. You could do personality, like we're going to do, try to confirm some personality structures. You could do clusters of behaviors, of forensic things. You could do different kinds of crimes go together, things like that. So there's lots of uses for it. We're trying to confirm it. In this case, we're going to take some latent variables. In our case, we're going to have one like type A. I think we decided on the first one maybe, and the second one maybe was warmth this morning, something like that. In this case, it's funny because the arrows go the other way. We run the arrows from the measured variables to the latent variable. It's just a way of designating that this variable is sort of made up of these. What we're trying to do is come up with a confirmatory fit that tells us how well our made-up variables here, our latent variables, really work with the measured variables we have. So you can use, and that's what you can use AMOS for very nicely to do that. So I do it a little bit differently. Let's turn it to landscape first. wants to know that I know where the data is coming from. Select the data from, whoops, find that data set. I didn't put it in there. Oh, I didn't load it. That's fine. So once that file's open there, and then you can do here, and it'll show it here. I got a different one.
Do you still have the other data file open?
Yeah, I do, I guess you're right. Where is it? Here. Title, here it is. We're done with 2 of 1.
Maybe you should open it again from the data.
Yeah,
You can,
here it is, so where is it?
Now go there and open another one from this data.
yeah. Go to Amos.
Open Amos again, maybe, huh?
Mm-hmm.
Yeah, I'll just,
And then just go to File and press New.
yeah, but see, those, here it's asking for Amos files, they have a whole different subscript, you can't put a data file in there.
I know, but if you open up a brand new one, you'll start.
There it is, I got it now. So it tells you, and you can look to see if there's missing values by that one. That's okay. I got it now. Now view, do it 5 times. Now for these variables, we're going to want these different kind of diagrams. So you can kind of save some time by using this little symbol here. Let's try and do just a simple one, a 2-factor solution for our things that we did this morning. So I'll click once, and then I click each time for each of the variables that are going into it. So let's do like 4 variables per each one. We'll just arbitrarily choose that one. I'll do another one down here. 1, 2, 3, 4. Also, I can rotate that so it faces the other way. And if I want to move it, I can click on this one so it moves it together with the moving truck. That one. Preserve symmetries. Then when I move it, it keeps everything together.
Did you click both?
Like that one. And I can resize it too so it fits on the screen. Okay, so this one gives us our unobserved variables here automatically right when we do it. Now we have to name those variables. So what I have to do is go into select data. Oops, wrong one. View variables and data set. That gives us all the variables we have. And look at your thing and tell me which were the top ones for the assertive, for the type A ones. What's forceful is the top one, or just whatever? Give me 4 of the top ones from that. It's on your output there. Forceful was one, I'm pretty sure.
Leadership, active leader.
Okay, wait a minute.
Forceful, assertive, strong personality, dominant.
Okay, forceful. See assertive there. Assertive. Leadership. Leadership ability, I think that was one of them. And done. And there's a way of fitting those into the boxes too, so I can do that. We need to name this one. To name this one, we do is right-click on it, do Object Properties, and it says Variable Name, so we're going to call this one Type A. And then when you click on this one, it'll wipe it out and lets us do, what do we decide to call this one? Warm fuzzy.
Teachers?
And which were the ones, what were the top ones for the second factor?
Passionate, sympathy.
Passionate. Let's find them as we go, that might be easier. Affectionate was one, wasn't it?
Yeah.
No?
That was in the third.
So in the second one,
Sympathy, sensitivity, understanding.
Yeah.
Soothe hurt feelings.
the warm, I don't know.
I blew it, so hang on. Yeah, let's see, I can do, you can do these separately too if you want, by just a separate box, but it relies on your artistic abilities, which I have not. All right, so tell me again which one's there. What's the first, you see one up there yet? Warm. You see warm yet there? No.
Yeah.
Soothe, I think, is one.
Soothe was one?
Yeah. Sympathy was one.
Where is that? Sensitive was one, wasn't it?
Yes.
Do we just want any of them, or do we want?
I just want the ones that are kind of going to work, right? So it doesn't matter if we get rid of more. We'll do these, that's good enough now. Let's see, one of these things resizes the boxes. That would make sense. Not going wrong. You'll figure it out. I'll leave it for now. If you go scroll over these, one of these. That one? No, that's change the shape. Yeah, no, that's different. One of these actually sizes them to the words perfectly. I can't remember which one. Where's that? Geez. Huh. No, it's there somewhere, but we'll work on it. I figured it out before once. All right, now we also need a correlation between the two. We don't think these are completely independent, so we need to connect those two. So we do the curved line there. I can resize that box. It's going to just see if I want to just there. Too much. Okay. Notice that it puts a 1 automatically at one of the paths. You have to designate a path arbitrarily for starting with a 1. Luckily, this does it for you, so you don't have to worry about it. Otherwise, it won't run the model. You also have to name these unobserved variables, just like we did last time. So name unobserved variables. It gives them E1 through E8. And I think, if I haven't forgotten anything, we want to do the analyses. Let's do the first analyses here. So we just either do it through calculate estimates. I want you to save it. CFA4, I'll call it. Okay, then if I want to click on this little guy, view the outputs, that gives us the unstandardized paths. But I didn't tell it to do the standardized paths yet, so that's all we're going to get for the start. You can see that we have pretty good high numbers here, but let's go ahead and do the view text. Let's do properties. But you got to tell it which output properties you want, and I need to tell it standardized estimates, modification indices, at least those two. Okay, now I run the model again. Here. Now if I'm lucky, I'm not lucky. Calculate estimates, paths, standardized estimates, yes, we got them. So now these are beta weights, which is what we really want. We don't want raw regression weights. So you can see the warm fuzzy, eager to soothe hurt feelings didn't work very well, sensitivity didn't work too well, gentle worked great, warm worked great. See the numbers? So you can kind of look at those like loadings. The top one, forceful was good, assertive was good, pretty good, leadership was pretty good, dominant was pretty good. So we got a pretty good model there, but you can see we're not going to get a great fit in the model because of the bottom ones. So now we go to the text, and especially model fit. Now, if you want to, when you get to your desks and do it, you can look at the book and see what all these things are. These guys being at 0.9 is very good. This one's not supposed to be that high, but that's just about okay. This number is supposed to be below 5. You'll never remember these, you just have to kind of look them up when you go. This one should be about 0.9. The RMSEA, let's see how we did in that one, should be near 0.05. With a large sample, it's hard to get these to be below that, but that's pretty close. So that model was decent, but probably could be better. And if you go to the modification indices, it'll tell you what the paths were for each of these. And you could look for any path that didn't work. These are like regression weights. And the other thing you can look for is look for correlated errors in the same one. So any numbers that are big, they can't be across latent variables. They have to be within the same latent variable. But like E2 to E4 is a pretty good sized number. So that means the errors are correlated. That means that those are not working. If the errors are correlated, that means those two are taking up too much of the same variance. So one way I can fix that is by putting a curved line between E2 and E4. That will help me a bit. And maybe between E1 and 3 and 2. These we don't care about. If it's going from the numbers to the latent variables, we don't care about. 6 and 7 maybe. Oh, look at 7 and 8 is really big. All right, so let's go back into the model. And what you've got to do is get back to here so that you get this one here. Now we're going to go to our double one from 7 to 8. And what did we say, 1 to 4? Was it the other one I was trying to do? Let's try that. Okay, estimates. There's your standardized model. Let's do the text. That took down those big numbers. That's better. Model fit. Yeah, it got better. Look at that. That one got a little lower. These got a little higher. Let's see if we even got this guy to be down below, a little bit lower for our SEA. So you keep on playing with it to try and see if you can kind of understand the model better. And then eventually, this is what you publish, basically. You can paste that into a Word document and publish it. And then you have your indices that show. And then you just say your modification, your fit numbers go in the text below. So now if you look at some journal articles here, you'll see how they do it that way. Now that's just confirmatory, but we use the same thing for structural equation modeling, where we're going to do more than just confirmation. We're going to do latent variables going to one another in some sort of a path with latent variables. And that's the ones that you see. Every article, right? There's like 5 of them in here. So I can't use them for decision trees. Well, there's a path model. Square box is a path model. That one's looking at childhood gender nonconformity. Trying to come up with a model for that. You can also use these charts if you want to just do like flow charts. It's an easy way to do flow charts. You can do it in PowerPoint too, but so here's one with both round and square ones with all the weights in them. That one's on maternal depressive symptoms, looking at a whole bunch of factors. I'll bring some in next time that you can actually see. Okay, so you want to try to do this? Oops, one time. Next time. All right, so next time, if you look at the book, it kind of takes you through it. So when we come in, can we save this data? Sure. Yeah, so save that data so we don't have to load it again. And you can make up your own models based on this morning's one if you want to. You don't have to do those very same variables I did. In the meantime, I'll figure out how to make the boxes fit the letters. It's going to drive me crazy until I get that. And next time we'll do it. Or if you want to stay and do it now, you can do it. Some of us will stick around. Or we'll do it in class next time. Okay?
Oh, I think our session ended.
Yeah, your time probably timed out. Oh, you may have lost it. We can do it again next time. I've got it on some thumb drives. Okay, and I gave you the concept list for the next couple of units earlier.
I don't have it. Can I have one?
Oh, no, this is after.
Did you get one? I gave you one.
I thought that was, I did my decision tonight.
Amber?
Oh.
Do you have one of these?
Very well for me.